Okay, hello everyone. Welcome to G Champion Conference 2023. Uh, we will share the knowledge with Victor Orozio from Guatemala on the topic from traditional to GitOps, a tale of modernized two government institutions of 1 year. Victor Orozio has a master in computer science. He's a leader of Guatemala JOG, and he Duke Choice Award in 2016 recipient, and he's professional trainer on EDX MicroMaster and consultant for Nebinik, I guess. He's a member of staff of the computer science department of Rafael Landiva University, and of course, he's a Java champion. He will talk about the impact of GitOps in modernized development culture by presenting two experiences. So I will let him to go deeper on the detail. Victor, you have the floor.
Okay, thank you, Constantine. And well, hello, everybody. I hope you are having a good conference. And first of all, I am glad to be back at J Champions Conference. So let's sit for a while and possibly establish a basic round in this presentation. My main intention with this presentation is not to demonstrate complex concepts about Java or about architecture, but mostly to describe a real world experience about what you need to do in order to be able to migrate traditional environments, let's name them monoliths, to cloud native environments. And I've been doing this for quite some time in my country, specifically in banking, telecom, and government environments. But the most important part of this presentation is to demonstrate what's the need of balance between doing the right thing in order to, do the migration, the steps needed to do this actual implementation, and some particular mistakes and errors that I made previously, and hopefully you won't do on the real life. So I think we are ready to share my screen, Constantine. So please go ahead by sharing the presentation. Okay, thank you. So traditionally, when an organization or a company starts to do this kind of migration implementation, most of the times it starts with a false premise. The premise is basically we are accustomed to do some custom software development for internal process in an internal deployment environment, basically our internal users. After a couple of years, if your system is successfully enough, like in the environments I will describe, being government, a system that has been working with internal users need to go to a new set of users, being the general public. In Guatemala, this means that many systems that have been developing internally in government institutions had to go live to attend the needs for Guatemala's population, being among between 16 to 17 million people nowadays. So when you start to do this jump between hundreds of people to thousands of people to millions of people, the first time we do it, we did that first mistake was to just launch the software expecting a good performance. But after that, a couple of days after that, the systems start to receive a lot of load that we are not accustomed to. And the first solution that raises is, okay, we are not able to manage this workload, let's go to the cloud. So the false premise goes like this: by migrating to newer cloud technologies like serverless, backends as a service, microservices, companies and organizations will automatically achieve scale. So the first step in order to go to the cloud for most of organizations that are accustomed to do traditional and on-premises deployments is more probably the scale. And the problem with this false premise is that you will not attain automatically scale by just going to the cloud. So this basically is the motivation to go to the cloud, but most of the times, or at least in my opinion, most of the projects that have been going to the cloud fail because the scale in the cloud is not about by just pushing a new monolith to the cloud, but you have to recreate the architecture and infrastructure needed to run your application. So what's next? When you start to research about what to do in order to really attain a scale in a cloud native environment, you will find, of course, the cloud native approach. So the cloud native is not an architecture, is not a movement, is not a set of patterns, is a mix of technology, concepts, and patterns. So basically, in my opinion, and a general definition that you will find on the internet is that cloud native is an approach for building modern computing systems and dynamic environments such as private or public clouds. But the main problem when you are starting with cloud native and your background, like myself, was on developing traditional implementation in application servers or servlet containers is that you will start to get a lot of new concepts, a lot of buzzwords, and most importantly, a lot of new things to learn. So when we started these migration projects, we started to research in books, in publication, in specialized providers about what to do. And from time to time, when we reviewed all of the resources, we started to receive messages like you have to create a reactive system, you have to learn the 12 cloud native factors, you have to research newer design patterns, microservices chassis. Okay, let's go with Spring, let's go with Micronaut. You have to learn Docker. Probably you have to go with Kubernetes, or probably not. Let's go serverless. Let's go backend as a service. So when you start to do this migration, the real amount of random things that you have to manage is quite a lot. So in order to do this, I had to research a lot. My team had to research a lot about how to do it properly, and we reached a basic conclusion. So what we really want when we want to go to cloud native is we want reactive systems. So what we need basically is a system that is able to scale by itself depending on the load and the actual demand on the system. It is actually able to downscale by itself in order to save money when you are running this on the cloud. And a battle tested approach to do it, of course, is the 12 cloud native factors. So we have two concepts. We want a reactive system architecture, and a methodology to actually do it is to, you know, to know how to do it with the 12 cloud native factors. And when you are actually developing the solution, the common mistakes and solution described by the software development community is the cloud native design patterns. So with that in mind, we start to take the actual system, and the basic conclusion that you will reach is each time on this kind of projects is that you have to divide the system in order to scale all of these parts independently. And a good approach to do it is by doing it by problem or by domain. So that's why domain driven design is important for this context. Just after all of the architecture design decisions and most importantly methodology, you have to learn about microservice chassis. And one mistake that I did previously and I see very often in the street is that people start by by saying, okay, let's destruct the monolith being achieved by Java EE, and let's create a greenfield system with Spring. So they start with the technology, but in the real world, you have to start this with technical decisions over the architecture. Later on, when you start to perceive that creating microservices is in the real world creating distributed systems, you have to create systems that are fault tolerant, that don't have automatic transaction management, that don't have centralized log management. So you have to learn a new set of technologies. After that, you have to learn how to run this on the cloud. So the cloud native migration projects, if you see this as a technology manager, are mostly macro projects. So what is a macro project in the end? If you have to migrate a system from traditional to GitOps, you have to do it with a proper approach, dividing this in sub-projects, and most importantly, the management of this kind of situation on this kind of projects is probably the difficult part of the project. I know that probably the people that is attending this conference is mostly Java developers. I am myself a Java developer, but when I faced this situation, because I was the main consultant for the projects, I perceived that my knowledge about Java wasn't sufficient in order to do a proper cloud native migration. Because after getting all of these concepts, after getting all of the literature, doing my proof of concepts and my pet projects, this wasn't enough because I wanted to lead a migration project, and this migration project in the real life are multiple projects that you have to take in account. So I started to research a lot about managing migration projects, but the thing is, this migration project doesn't have a clear and globally accepted approach. You will find some suggestions on the internet. You could go to Reddit, you could go to expert domains. But in the end, I decided that I have to go back to the fundamentals, and I had to look for a methodology in order to do this, taking in account that I am a consultant, I am an external consultant that is working with some government institution. So what was my conclusion? First of all, I need a methodology in order to have an structured approach to do all of this. So researching about it, the first and most valuable resource that I found on the internet was this particular slide. This particular slide was presented in a Vodafone's Cloud Native Journey keynote because they were describing what was their actual experience about going from traditional systems to cloud native systems. The thing that I was doing, but I am not Vodafone. I am a consultant working with two teams, my teams and my client team. Vodafone describes the migration project in a 4 steps or 4 levels that you could attain by migrating your system in order to go cloud native. The first step is probably the most common step in traditional institutions, being the legacy level. In the legacy level, you're probably creating or you're probably managing systems in the traditional way, in which you actually went to a provider, you acquired proprietary hardware implementation, and you have a license for a particular software that only runs on that hardware. I know nowadays that's not so common, but if you are working with an established institution like myself, I am working with institutions that have been doing software for 40 years. So the legacy software matters. The software is there because it has been successful for a lot of years. So the first step that any organization takes, if they take the software architecture and design principle from the 2000s, is to go from legacy to virtualization. So the main idea of virtualization was because we needed to save money. The money is a constant in every project in the IT industry, but the general idea in the virtualization is to take advantage of your actual hardware. So in order to logically divide the workload and the responsibility of any of the moving parts of any software project, we divided the workload in virtual machines. So with the virtual machines, we started to see the rise of VMware solutions, KVM on Linux, and we started to see the first implementations on the cloud being the virtual private servers. And the virtualization is a good first step, but most importantly, if we want to achieve scale via virtualization, we basically have to duplicate virtual machines that don't start fast, that spend a lot of resources, but most importantly, we don't have a structured process in order to do the software delivery. So before going to the entire cloud native stack, you have an intermediate step named by Vodafone as cloud ready. In cloud ready, you will automate the full pipelines of building, testing, preparing the artifacts in order to be in deployment. You have to start to think about how do I deliver software, how do I manage different environment for testing, for certification, and for production. And most importantly, I have to automate all of this, not by creating virtual machines, but by using infrastructure as code. And at least in my opinion, and that's my general panorama here in Latin America, I'm not sure about other countries, but here in Latin America, many traditional organizations are between these two levels. They already have virtualizations because this is we take for granted the virtualization, but the cloud ready process in which you start to see the DevOps practices is not 100% ready, but people still want to go with microservices because it is a buzzword that sounds great, and there is a lot of success cases with microservices. So the final step in order to be cloud native is actually being cloud ready, being ready with all of the software engineering process of delivery, the continuous integration deployment. And just after that, and we could actually achieve the cloud native era in which we could be 100% IP driving. We start to see new deployment models like being stateless, or infrastructure is self-healable. In other words, if something goes wrong with our infrastructure, it reconstructs itself. So we have the opportunity to auto scale it. But that's the final step of a complex project. So as in my case, if I start with an organization that has virtualization, that has legacy infrastructure, before going and starting to develop microservices with Spring Boot or Quarkus or Oracle Helidon, I have to be cloud ready. And that's the tricky part. You have to create a micro project in order to be able to go step by step and reach the cloud native scenario. So how does this look in Java? I will talk about a little bit the migration projects, and probably if you have questions, please let them there. We will answer this in the final phase of the presentation. So as I started this presentation, I said, okay, I was working with the government here in Guatemala. Guatemala is not a small country if compared to many countries in Latin America. We are a lot of people, and some of these projects are still on the initial experiment, but still I could talk about a little bit the previous infrastructure that they had in order to give attention. So they have two systems that have these particularities in which they received a lot of information during the day. The traditional systems were aimed to be run on the web, but these weren't systems aimed for the final user. These were systems aimed for internal people or IT people that was basically in a government dependency, attending the user and doing all of the work needed on a computer. But a modernization project came in the last 5 years in which they said, okay, we are a lot of Guatemalans. People is asking a lot for doing all of this process in a more agile way. And most importantly, we want to switch this attention from internal people at our departments to be able to present this same process in a mobile application. But you are basically switching by having 1,000, 2,000 people working in the government sector to millions of people trying to do the same in a mobile application. So they had this basic, let's name it basic, because these were actual and functional projects in which one institution had this Node.js based solution. And despite using Node.js and Docker, it was a monolith because they had like, I remember between 30 to 40 microservices being packed as a Docker containers, but every Docker container was running on the same machine actually. So they had like this 128 gigabytes of RAM machine attending all of the requisitions. And when they launched this to the general public, it basically failed really, really bad. We had news in the newspapers here in Guatemala. So they decided, okay, we need to re-architecture this. We are using last generation technology, but this thing didn't work. The second project in which we involved Java, they had a long-running Java EE based solution. Java EE by itself is a great technology, but the problem was basically the same. They were starting to do this kind of cloud native unorganized effort in which they have an Apache Tommy based monolith. They started to decompose the monolith in many Apache Tommy instances. But most importantly, the second institution wanted to go microservice cloud native Kubernetes era without being cloud ready. so they didn't have any CI/CD process at all. But still, these systems were useful for Guatemala's population. Both systems provided services for 16 million potential users. And most importantly, they wanted to provide service between to users rangers to 1,000 to 5,000 users at any time. So this was a titanic project, and when I faced this, I started to worry about it because, okay, I know Java. I've been doing a lot of microservices deployment, but you could see here why this is difficult. My main difficulty was not the technology. I know how to manage Java, how to manage Node.js, how to manage Docker and Kubernetes. This was a software engineering project. As a software engineering project, you have to focus this as a software engineering project. So how I did it, what mistakes I did, let's talk about a little bit. Well, after fighting a lot with my internals as a software developer and basically accepting that not everything could be solved by code, I started to research again about approaches to achieve this kind of mega projects. While talking about with people in the software development circle, they told me you basically need the PMI approach. I'm not a PMI. I know that for sure that PMI is not so popular if compared to agile methodologies, but PMI is still strong here in Guatemala. So talking with these professionals about my endeavor in doing these two migrations, they told me, okay, you have the technology, but you're still lacking a good approach to do it. So let's create your own framework of work in which you could divide in different phases by using the PMI approach. So they told me, okay, in PMI principles, you have basically 5 phases on any kind of project, being an IT project or not. Any project has this conception and initiation, definition and planning, launch or execution, performance and control, and a project closure in which you close the project, you do the billing, and you receive your money. So that's basically, we are doing business in IT. You have to map all of your efforts on all of your visualized efforts to the PMI approach, being these 5 phases on any project. And let's do it. I did it in a couple of weeks, and I presented this to the government institution in order to be able and receive the approval in order to start my efforts. So how I did it and which were my lessons on these 5 steps. First one, when you start a project like this, you have to sit with the stakeholders and decision makers. And this is really important and doesn't have to any relation with software development at all. This is mostly software management and IT management. So my suggestion, I started this with a quick meeting with no more than 2 brainstorming sessions. We sit down by 2 hours on average, in which we discuss it. Okay, which are your actual problems, which are the proposed solution, why this is not working, and what do we need to actually do a cloud native implementation with Java or with Node.js. So the mandatory stakeholders to participate in this kind of meeting, and I perceived this on the first brainstorming session, was to at least sit down with the software architect, being a tech lead, being a developer with a seniority and respected by the entire development team, being also in direct contact with the infrastructure team, being a senior sysadmin or a software reliability engineer, and most importantly, to establish a direct contact point among the team that you are doing, that you are helping to migrate, and your team. That's why I did. So the key questions that I did in this step was the actual motivation to do this. I described the motivation because now I have the entire picture. But in order to establish the previous picture that I described in the previous slides, I had to ask a lot of questions. Once I had the entire picture about the motivations and the actual state of the system, I had to define and to establish a migration plan in order to take in account the actual current team size and skills. Not everybody is Amazon, not everybody is Facebook, not everybody is Netflix. I had to work with the team that I had at that time. And most importantly, what's the actual tech stack? what's the possibility of taking advantage of that tech stack, and what could we do in order to take advantage of the actual knowledge. So that was the concept and initiation. So let's talk about a tool for this. A good tool for this, and jumping to the next step, to the definition and planning, is an architecture review. The architecture review, it has one particular objective, just to found all of the issues that you actually have in your architecture. But besides finding the actual issues, you have to propose possible and achievable solutions, but most importantly, with actions. As a result of your proposal, you will finish an architectural review with a clear roadmap for all of the stakeholders and decision makers with options. The options means, how do I solve this? And you could solve it in three ways: by hiring consultants, by hiring an outsourcing team, or by training and support. And most importantly, and my really big mistake on when I was starting this kind of projects, is that I wanted to do it in a big bang approach from start to end. So when I found a lot of difficulties on the road, I wasn't able to ask for money to actually deliver a bill, because I didn't create my contract based on deliverables. I did a big bang contract, and that was an issue that actually impacted financially the entire state of the project. So my suggestion, please do this based on deliverables. Don't try to do this in a unique effort. Do it properly. So the tool that I use by this, I researched for a lot of tools in the C4 architecture, and TOGAF, the PMI also has these templates. But okay, let's go back to the software engineering project, the software engineering world actually. As software engineers, as Java software engineers like myself, I don't want to do a lot of documentation. And when I was researching about the TOGAF principle, TOGAF documentation, I was feeling again that I was doing a rational unified process thing, and I didn't want to do that. So I took a different approach, and I actually researched for quick templates in order to do an architectural review. And I stumbled upon this template by Atlassian. This template was simply enough to actually achieve perceivable results in a short period of time in order to do the cloud native migration. So let's see the example. This is in Spanish because this was achieved in Central America, but this basically divides the macro project of the big project in mini project, in which you give a brief description. How much time from experience do you believe that this will take? And most importantly, the opportunities and actions that you could do. So in this, I actually did the divide and conquer approach, but in a software engineering way. And I decided which were the actual next steps in order to do the cloud native migration. So later on, okay, we have a plan, we have a roadmap, we finally have all of the solutions, all of the software development needs, all of the infrastructure needs. Let's go to the execution. In the execution, okay, I am going back from the software engineering world to the IT management world. In that, I have to establish a contact point. I had to establish direct means of communications, because when you are in the middle of a Kubernetes cluster installation, when you're in the middle of a Linux rebuttal, you want to actually have a direct means of communication to speed up things. But most importantly, and this is another mistake that I did, if you want to deliver something that probably is the basis of your contract, you have to do it by non-repudiable means, being an email. Because if you deliver this by WhatsApp or by Telegram or by any means of communication, being a direct phone call, if you don't have record of it, people will forget what you actually were delivering. So please do this over non-repudiation means like the email. In the end, we concluded that in order to be able to migrate to cloud native, we have to tackle two main problems: the software development culture and the software development infrastructure. By itself, each of these is a new project, and we have to respect that any project has its own difficulties. So in the cultural side, we have to establish DevOps practices, and most importantly, test driven development, because remember, we want to achieve cloud ready in order to go to cloud native. being a DevOps aware organization and a test-driven development team is being cloud ready. After that, we have to secure the infrastructure. Most importantly, we have to establish policies for remote access because we are not running on the cloud, particular software selection about what BCS we will use, what CI/CD platform we will use. And most importantly, we have to benchmark all of the cloud native platforms that we had available. In the market, you will find people recommending OpenShift, you will find people recommending Kubernetes or managed services like Amazon AKS or Oracle Kubernetes Engine, but you have to benchmark in relation to money, in relation to performance, in relation to easiness of management. And once you have the platform, because we decided to go by microservices over Kubernetes, we have to start to worry about the extras in Kubernetes. One thing is to have the actual Kubernetes clusters in order to run your workload. And another different problem is to have a cluster managed by a software reliability engineer. So the observability metrics, the log centralization, the telemetry and tracing on transactions is a problem by itself. So each of these that I am presenting this in these slides were the actual mini projects. So we established that this will be delivered in 3 months, this will be delivered in 2 months, and we started to add up more and more months of consulting in order to be able to do it in a proper way. So you should ideally make one presentation or technology transfer process per deliverable, because when you start to deliver things, people start to perceive what is good about this migration and how could I use it. So we started to implement DevOps and test-driven development, not over a new Kubernetes cluster, because we perceive it that if we start with the infrastructure will be there for a lot of time and people won't be using it. On the other side, we started with the actual monolith. Okay, let's create some pipelines. Let's create a well-defined delivery process. Let's create artifacts repositories. And once we are ready and software developers are accustomed to do this, okay, we could now invest in newer infrastructure, newer cloud, and we could actually do it in a proper way because now we have the need and the knowledge, the basic knowledge to actually take advantage of this. So other mistake that I did on each of these mini projects, it was that I wanted to create the documentation at the end of the delivery. I did that especially on the DevOps phase. The problem with this is that you have to create documentation that is adaptable over the time, because the infrastructure, the policies, and the methodologies that you will use, you should adapt this to your organization. So this will be changing, and you have to take for granted that this will be changing a lot during project executions. So you have to do training and development in different things like bootstrapping architects or PEP projects. You have to train on how to use Maven, how to use NPM, how to use Gradle. After that, you have to define process to create test-driving microservices, domain-driven design, which microservice chassis is acceptable for this project. So each of these, being technical problems, is actually also mini projects of the mini projects. And most importantly, and my mistake was to try to document all of this on the end of the project. Please don't do that. You have to assume that you will be producing live documentation. And how to manage this live documentation? You could probably use some documentation software, some documents management software, but in the end, what I found that worked better for our teams was to document this directly on a wiki. So after defining all of the execution of the DevOps area, we started with code and building, but we have to document the integration, the testing, the release, the deployment, and the operation side. So this takes a lot of effort. So how to do this? We started to create all of the executions over GitLab, and we chose GitLab basically because it is free. So nowadays, they actually are running in a hybrid between GitLab on premises and GitLab as a software as a service. But in the beginning, and one advantage that GitLab has for my environment is that they were starting on-premises side, and they have this kind of rule in which you couldn't push source code outside the organization. So we created a new infrastructure in order to be cloud ready, not still not cloud native. And once we defined these pipelines in order to do the continuous integration and deployment, we started with the performance and control. So no, we are now ready to the cloud ready journey. And we started again from the software engineering side and from the IT management side. The performance and control in this kind of projects has two point of views. The technology point of view of going cloud ready in order to do the jump to cloud native is by taking metrics like code quality, like test coverage, code smells, bugs, vulnerabilities, like in the classic Sonar way. Performance, like network latency, and most importantly, what to do about failures. What happens if the network goes down? We have to do a lot of training and support for this. We have to simulate what will be our recovery process, the instrumentation of all of the infrastructure, and how many services have been migrated. But on the project side, we kept asking a lot of money for doing this. So the project side, and probably the most important metric on the performance on the project side, is the budget. How much money are you spending on this? Are you choosing an open source implementation? Are you paying to this provider? Do you plan to do it in the future? Are you going with a proprietary solution? And most importantly, how do you balance the deliverables versus the deadlines? And finally, an informal metric that actually makes sense in this kind of context, how the users are perceiving the newer functionality. Are they receiving better functionality faster than ever? Are they perceiving at all that we are doing this effort in order to go cloud ready? And probably also to ask about developer perceptions. In both of the use cases, the users were the final judges about if this was a good or bad project. In the end, it was good because they perceived that they were receiving a lot of new features fast. And most importantly, when this system went to the public, it actually liberated work from them and they were able to do a lot of things additionally to the just being in the computer typing things. So the performance and control on the technical side, my suggestions, if you wanna do and you wanna check all of these particular performance metrics on your code, you have to install some kind of tool for static analysis. My perception, SonarQube is still the best tool for this on premises because it is easy to install, it is easy to manage, and most importantly, is well integrated with Maven. So in order to integrate SonarQube with Maven, it is basically to you just communicate the source control system being in this case GitLab, and the connection among this was automatic. With this, I had a general panorama about how much test I have to write. I established some particular rules for this environment, but most importantly, now I had a picture about what to improve in my organization. What about the instrumentation? When we did finally the jump between cloud ready and we started to use our Kubernetes platform, we perceived that it's not the same to manage one or two monoliths versus to manage a lot of microservices, a lot being 100, 200, 300, and my final count was at least 300 microservices with a lot of copies. So with this, you have to use smarter tools, which is my suggestion. If you do a complete kube Prometheus install process, you will get Grafana, you will have Prometheus, and most importantly, you have to install in your Kubernetes cluster an instrumentation being also capable of sending metrics. So in our case, it was Linkerd. So with Linkerd, we had this historical data about what's happening with the network, how many requests are being executed over each of the microservices. So we have these fine-grained metrics over each of the microservices. But most importantly, it also help us in order to reach fault tolerance, because it has fault tolerant features when you deploy a sidecar with Linkerd over a Docker implementation, over a Kubernetes implementation. Okay, so finally, how do we close this kind of projects? Okay, we discussed basically that a cloud native migration, a GitOps migration actually, has different steps. At first, you have to establish a macro project. You have to divide this macro project in mini projects achievable by doing each project on steps. But most importantly, once you are ready with the macro project, being cloud native is a continuous effort. So you have to close this properly. And first of all, and the mistake that we did, we actually had to discuss a little bit about it, is who will support this? Who will be in charge of supporting all of this effort? Because Kubernetes is a complex infrastructure, or pipelines are complex enough in order to be able to support development, certification, and production environments. So who will support this? So as part of the closure of the project, you have to transition your project to support. You won't do this and forget about it. That doesn't exist. You have to do a proper transition to create also a support team if you don't have this on your organization. And this is why live documentation matters, because when you transition this to support, the infrastructure will change. Some new features will come from the Kubernetes platform you decided. Some newer features will come from the Java versions that you decided. So you have to create live documentation. And most importantly, you have to ask to your team and to yourself what could be done better. So we actually always have area to improve our efforts. So in the closure of the project, we finish this project, because I say finish because my consultancy effort finish at that point, but I know for sure that this is for infrastructure is still running. In the closure, the live documentation media that we decided was wikis. So we created a general wiki in which we saved all of the decisions that we made, why we did it, and most importantly, who is responsible for manage this infrastructure. Inside every of the microservice, because GitLab is able to do this, we created particular wikis. So we have the configuration side of one microservice documented directly on every repository. I know you could have different opinions about it. You could probably use Confluence. You could use MediaWiki to document this in a central point. But the thing is, in this kind of institutions and this kind of environments, there is a lot of changes going on. People changes, people leave, newer persons come to support this. So we found that if we document this on a central point, no one continues the documentation. That was my experience. Probably is not the same experience on every other institution and organization. But in our case, the only way that people actually perceive the documentation as valuable is when they open every microservice on their IDE and they saw the actual documentation, how to run this, what software do you need to run this microservice, what will happen if you do a commit to develop, what will happen if you do a commit to main, which verifications will be running on GitLab, and finally, how this will be playing together in order to be able to create good microservices, good engineering process, and most importantly, deploying Java cloud native. So my final opinion, this was a short presentation. When you want to migrate traditional projects to cloud native, Java will be the least of your problems, because Java is a battle-tested technology. You could go easily between Java versions. If you already migrated from Java 8 to Java 11, it is really easy to go from Java 11 to Java 17. Java has a lot of newer frameworks in order to do cloud native development, and that area is basically covered. So Java got you and got your back. In the same time, I didn't had a lot of experience on Node.js, but I saw that the Node.js environment also has this. It is mostly an opinionated and friendly dispute among these two organizations because they were basically brothers organization. But in the end, the technical side, once you learn actually how to use properly the microservice chassis, Spring Boot is a microservice chassis, Quarkus is a microservice chassis, Node and Express are microservice chassis. That's only a little part of the problem. The actual difficulty will be on how to manage this effort. So I presented to you this tale. I know for sure that this is probably not a generalistic framework of doing things, but I wanted to share with the community the lessons I learned, the mistakes I did, and probably some of these key ideas are useful for you. And if you have any questions, please feel free to ask directly on the chat. So, Konstantin, I don't know if we have questions. I think you are on mute.
We have no question. So we have one question, sir, that I will show to you.
Okay, Vincent, could you explain what? Sorry, I didn't saw the
What
question.
makes a project to digital project?
Okay, so once you are in cloud native, probably you decided to go with Kubernetes. Let's focus on the Kubernetes side of things. When you start to do the CI/CD process, at least the first approach that I used was to use some plugin being Eclipse JCube in order to generate Kubernetes manifests. So we have this communication in which your CI/CD platform creates the deployment plans and communicates with the Kubernetes cluster in order to say, please, Kubernetes cluster, deploy this. On the GitOps side of things, one of disadvantage of the thing that I did previously was that I wasn't sure about the actual state of every microservice. I knew for sure that the pipelines ran and the microservice deployment plan was created on the cluster, but at any given time, I wasn't sure about the actual state of things. So with a GitOps platform, the basic idea is to have a Kubernetes cluster and deploy a GitOps platform inside it. The most popular platform nowadays is probably Argo CD, and Argo CD flips this concept. So instead of being the CI/CD platform pushing new deployment plans to the Kubernetes cluster, Argo CD running on Kubernetes pulls the deployment plans and the infrastructure as code from the CI/CD platform. So when you deploy Rancher with Flux or Argo CD, the basic difference is that your pipeline is not in charge anymore of doing the deployment. Your Git platform is in charge of being the single source of truth, and the Kubernetes operator, again Argo CD, pulls these plans, deploy this, is being in charge of deploying everything. If everything goes right, it basically gives you a green light about, okay, everything is running well. But if something goes wrong, it actually will show, okay, everything, we have some problems with this microservice, we are having some issues, please check it. So I will say that the difference is that you will have an actual operator inside the cluster that pulls the deployment plans. It is in charge of recreating the actual state of your infrastructure, and you will have a single point of consultant to query the actual state of the deployed infrastructure. So that will be my answer.
Thank you, Victor. We have no more questions for the moment.
Okay.
Probably we'll wait for a while. No questions?
Okay, so again, hopefully
Okay.
this will be helpful to someone. But thank you for attending this presentation. And Constantine, I
Okay.
know
It
the
has
floor
been
is
a
yours.
great presentation. And I think it has been a great presentations, and that will be an experience that people will be based on to build a strong infrastructure, a strong uh, infrastructure for their project in the future. Thank you, Victor, and
Okay, thank you.
probably see you next. And happy
Okay,
G champion, G.
okay, thank you to you, Constantine. It was great to share the screen with you again. And thank you, whoever who attended this. So bye bye, and please enjoy the conference.
Bye.